So tonight we're going to talk about rationalizing the denominator. So I'd like you to put me on pause, do the try this, and then come back and check your answers. Okay, so hopefully you identified which numbers are rational and which numbers are irrational. So just quick thing is rational numbers are numbers that can be written as a fraction. And irrational numbers are numbers that go on forever, a decimal that goes on forever that does not repeat. Okay, so let's take a look at 4. 4 is a rational number because it can be written as a fraction. It's written as 4 over 1. 1/2 is a rational number. Pi is irrational because pi is 3.141596 ... just keeps going. So this is irrational. The square root of 36. Well, the square root of 36 is 6. So that is rational because that can be written as a fraction, 6 over 1. The square root of 6. So plug that in your calculator, the square root of 6, and you get 2.4494897 ... It just keeps going on and on and on. So that is irrational. All right, so the next thing says determine what number to multiply each expression by to get a rational number. So I have the square root of 2. Square root of 2 is not a rational number. So what could I multiply it by so that I do get a rational number? So what about multiplying by the square root of 2? If I multiply by the square root of 2, I will get the square root of 4. And the square root of 4 is 2, and that's rational. All right, what about the square root of 7? Well, if I multiply the square root of 7 by the square root of 7, I'll get the square root of 49. And the square root of 49 is 7, and that would be rational. What about 3, the square root of 8? So the 3 on the outside, that really has nothing to do with it. So I could multiply the square root of 8 times the square root of 8. This will give me 3 times the square root of 64, which would be 3 times 8, which is 24, and that's a rational number. So you can see when I have the square root of 2, I multiply by the square root of 2. That gives me a rational number. If I have the square root of 7, I multiply by the square root of 7. It gives me a rational number. It gives me a perfect square, which is 7. I had 3, the square root of 8. So I didn't do anything with the 3. I just multiplied by the square root of 8, which gave me a perfect square, which gave me a rational number. So when you have these radicals, you just multiply by the radical. Whatever radical it is, whatever radicand is underneath the radical, that's what you multiply by. So that will help us with rationalizing the denominator. So when you rationalize the denominator, the first thing you're going to do is identify the radical that is in the denominator. And then you're going to multiply the numerator and the denominator by that radical. You're going to simplify and reduce. All right, so let's take a look at the first one. I have the square root of 2 divided by the square root of 8. So I'm not worried about the numerator. I'm worried about the denominator because the square root of 8. The reason why we have to rationalize the denominator is because the square root of 8 is equal to 2.828427125, and it keeps going. So how can I possibly take this number that just keeps going on and on and on and divide it into my top number when it just keeps going on? That's the reason why we rationalize. So I have the square root of 8 in the denominator. So I'm going to multiply the top and the bottom by the radical that's in the denominator, which is the square root of 8. Now we're going to simplify. So I have in the numerator, the square root of 2 times the square root of 8 is the square root of 16, over the square root of 8 times the square root of 8 is the square root of 64. The square root of 16 is 4. The square root of 64 is 8. So this is equal to 1/2. All right, let's take a look at 2. I have the square root of 10 divided by the square root of 5. So what radical is in the denominator? The square root of 5. So I'm going to multiply the top and bottom, numerator and denominator, by the square root of 5. So the square root of 10 times the square root of 5 is the square root of 50 over the square root of 25. Now I have to simplify. I can't take the square root of 50, but I can simplify the square root of 50. What perfect square goes into 50? The square root of 25 and the square root of 2. And what's the square root of 25? 5, and then I have the square root of 2. Over the square root of 25, which is just 5. And now I can reduce. I can reduce 5 and 5. Remember, this is multiplication in between, so I can reduce. 5 and 5 reduce to 1 and 1. So my answer is the square root of 2. So even though I have a radical in my answer still, I don't have a radical in my denominator because this would be over 1. All right, let's take a look at 3 and 4. All right, so let's take a look at 3. 9 over 4 the square root of 20. So what is the radical that's in the denominator? The square root of 20. So we're going to multiply the numerator and denominator by the square root of 20. So in the numerator, I get 9, the square root of 20, over 4 times the square root of 400. Now 20 I can simplify. It's the square root of 4 times 5, which is 2 the square root of 5. But I have the 9 on the outside, so I have to make sure I multiply that by 9. So that's 18 the square root of 5 over the square root of 400 is 20. So it's 4 times 20, which is 80. And then I can reduce 18 and 80. So 2 goes into 18 9 times. And 2 goes into 80 40 times. So this reduces to 9 and this reduces to 40. So it's 9 the square root of 5 over 40. All right, let's take a look at number 4. So I have, notice in the numerator I have 5 minus the square root of 6. That's a binomial. Divided by the square root of 2. So in the denominator I have the square root of 2. So I'm going to multiply the numerator and the denominator by the square root of 2. So now you do have to be careful because in the numerator it is a binomial. So you're going to have to make sure you put parentheses around it. Let me just rewrite that. Multiplying by the square root of 2. Make sure you put parentheses around the binomial and make sure you distribute. So the square root of 2 times 5 would be 5 the square root of 2. The square root of 2 times the square root of 6 would be the square root of 12. So that's minus the square root of 12. Over the square root of 2 times the square root of 2 is the square root of 4. All right, now I have to simplify the square root of 20 to see if I can, square root of 12, see if I can simplify, reduce anymore. Square root of 4 is square root of 3, which is 2 the square root of 3. So I have here 5 the square root of 2 minus 2 the square root of 3 over 2. And now I'm going to see if I can make a heart and reduce. Is there a number that goes into 5, 2, and 2? No, so then that's my answer. 5 the square root of 2 minus 2 the square root of 3 all over 2. Okay, so that's it, and have a good night. We'll practice in class tomorrow.